Day 377 of doing a LeetCode problem every day until I get a job. Alright, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2900, longest unequal adjacent group subsequence 1. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. You are given a string array words in a binary array groups, both of length n, where words of I is associated with groups of I. Your task is to select longest alternating subsequences from words. A subsequence of words is alternating if for any two consecutive strings in the sequence, their corresponding elements in the binary array groups differ. Essentially, you are to choose strings such that adjacent elements have non-matching corresponding bits in the group's array. Formally, you need to find the longest subsequence of an array indices 0, 1 up to n-1, denoted as I0, I1 up to ik-1, such that groups ij do not equal groups ij plus 1 for each 0 is less than j and j is less than k and k is and j is less than k minus 1. And then find the words corresponding to these indices. Return the selected subsequence if there are multiple answers. Return any of them. Note, the elements and words are distinct. Alright, y'all, so I could understand how that was a lot to take in and it may be difficult to understand for everyone. So let's go ahead and take a look at these examples just to make sure we are doing this problem correctly. So in example 1, we have the input words equals an array of strings E, A, B, and groups is an array of integers 0, 0, 1. The output is an array of strings E and B. Explanation says a subsequence that can be selected is E and B because groups 0 does not equal groups 2. Another subsequence that can be selected is A and B because groups 1 does not equal groups 2. It can be demonstrated that the length of the longest subsequence of indices that satisfies the condition is 2. Okay, y'all, so just in case you didn't understand that, let's go ahead and break this down one step further. So as you can see, each of these, as it says right here, where words of I is associated with groups of I. So each of these, right, each indice in groups corresponds to the character in words, so, or vice versa. So since words has E at index 0 and groups has 0 at index 0, we have to find another element that does not equal 0 in groups, right? So we can't go from 0 to 0 because that's the same. So we have to go from 0 to 1. And once we go from 0 to 1, that's like going from E to B. So that's why the output is E and B. It also says we could do A and B because as you can see, A corresponds to index 1 in words, so that corresponds to index 1 in groups, which is 0. So also 0 and 1 is not the same, so that means we can use this substring as well. We want to create the largest substring possible, y'all. So once again, we're just looking at groups and we're checking to see if the elements are the same, and if they are the same, or excuse me, we're checking to see if the adjacent elements are the same, and if they are the same, we keep going down the indices until we find an element that is not the same, and we add those corresponding elements and words to our output array. So in case that didn't make sense, I hope it did, but let's go ahead and take a look at example 2 just so we can really make it make sense to everybody who still may be confused. So in example 2, we have the input words equals an array of strings A, B, C, and D. Groups equals an array of integers 1, 0, 1, and 1. The output is A, B, and C. Explanation says a subsequence that can be selected is A, B, and C because groups of 0 does not equal groups 1, and groups 1 does not equal groups 2. Another subsequence that can be selected is A, B, and D because group 0 does not equal groups 1 and groups 1 does not equal groups 3. It can be shown that the length of the longest subsequence of indices that satisfies the condition is 3. So once again, each string in this array corresponds to each number in this array, right? So we could go from 1 to 0. That means we can include A and B in our subsequence because 1 and 0 is not the same. Then we can take it one step further and go 1, 0, and 1, and we can add C to our subsequence. So we can have A, B, and C in our subsequence because 1, 0, and 1 is not the same. We also are allowed to skip over this one and go to this one. Since these two ones are the same, we can create a subsequence using 1 and 0, and then we can create two different subsequences using each of these ones. So if we went 1, 0, and then use this one, that'd be the same as going A, B, and then using this D, which is allowed as long as we don't use two consecutive elements in the same at the same time that are the same. Two consecutive elements that are the same in the same substring, we're not allowed to do that, but we can break them up separately. This is one substring, and this is another substring, which is right here, A, B, and D. So now that we understand the question, y'all, let's get into the fun part, the actual solution. The solution is not that difficult at all, and make sure y'all stay at the end because I have two solutions today for y'all. So if you want to check out both of the solutions, stick around. They're both quick, simple, and easy. We should get through this really quickly. So let's get started. Now, the first thing we need to do is we need to initialize our result array with the first word because it's always going to start a subsequence. So for that, we could just come right here, declare a variable called result, and we can set that equal to an array and pass in words, square bracket 0, just like that. Now we need to iterate through the groups array starting from the second element. So for that, we can come right here, we can say for I in 1 dot less than groups dot count. We can open up the brackets, and if the current group is different from the previous one, it means we can extend the subsequence by adding this word. So for that, we just say if groups square bracket I does not equal groups square bracket I minus 1, then we can open up the bracket and we can say result dot append, and we are going to append. Remember, the indexes correspond to each other, so we're going to append words square bracket I because that will be the same I corresponding from groups. Then we just return the longest valid subsequence that we were able to find by coming right here outside of the for loop and saying return result. Boom. So let's run it. Make sure it runs first before we submit it. Let's see. And it's accepted, y'all. So let's go ahead and submit it and make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 0 milliseconds beats 100% of users with Swift. Now, with that being said, guess what? I told you we had another solution. I had another solution for y'all. And guess what, y'all? We got a one-liner. That's right, this is one line of code, so I wanted to make sure I included it in this video so we can all take part in this one-liner together. You know what I mean? So the first thing we're going to do is we're going to start the result with the first word, similarly to how we did in the previous solution, because it will always be included in the subsequence. So for that, we're just going to say words square bracket, or sorry, start. We're going to say square bracket words square bracket 0, just like that. Then we're going to come outside of that. We're going to say plus, and we're going to say zip, open up the parentheses, words square bracket 1 dot dot dot. Boom. So that's going to pair each word from index 1 onward with a Boolean indicating if the group has changed. So for that, we're going to come to add the Boolean part. We come right here, say comma, and we say groups dot adjacent. Sorry, y'all. Adjacent pairs parentheses dot map, open up the parentheses, exclamation point equals. So once again, this is going to pair each word from index 1 onward with the Boolean indicating if the group has changed or if the group index has changed, or the group element, I should say. If the group element has changed, it's going to return a Boolean. Then we need to keep only the pairs where the group changed is true. So for that, we come right here, and for that we just say dot filter. Then we open up and we extract just the word from each remaining pair. So we say open up the parentheses and we say slash dot 1. Come outside of those parentheses and we say dot map. Open up some more parentheses and we say slash dot 0. Just like that, y'all. And that should be all she wrote for the one-liner. Let's go ahead and give it a run. Make sure it runs properly before we submit it. And it's accepted, so let's go ahead and submit it. Make sure it's still accepted. Let's see, and look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. Those are some good numbers right there. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.